In this video, let us derive Einstein's mass energy relation E equal to mc square. This relation E equal to mc square is the most famous of all physics relation because even a layman can remember this. This relation establishes the relationship between mass and energy existing in the universe. Okay, now let us start by defining what is force. We all know the force is defined as the rate of change of momentum by Newton's second law of motion. Yes, as per Newton's second law of motion, the force is defined as the rate of change of momentum. So, rate of change of momentum means F is equal to dp by dt. But we know the value of P is equal to m times v, where m is the mass and v is the velocity. Now, let us substitute this mv in place of P. So, we get d by dt of m times v. So, F is equal to d by dt of m times v. Let us take it as equation number 1. And according to relativity, the mass m and the velocity v are variable. That means in relativity, the mass is not a constant quantity as we do it in a Newtonian mechanics. Here both mass and velocity are variables. Now this is the differential formula which will help us to do the differentiation if there are more than one variable. So here u is also a variable, v is also the variable. So d of u times v is equal to u times dv plus v times du. This is the differential formula. Let us do the differentiation using this formula in equation 1. When we do it, we get F is equal to m times dv by dt plus v times dm by dt. So first I am keeping here u is m and u is m, v is v, the velocity. So keeping the m constant, we differentiate v, that is dv by dt, plus then keeping the v constant, then we differentiate u, that is dm by dt. Let us take it as equation number 2. Then this force represented by equation 2 displaces a body through a distance dx. This force F displaces a body through a distance dx. Generally in physics, if a body is displaced, then we define that as work being done. So according to physics, if a body is moved through a certain distance, we define it as a work. So the formula for work is equal to force into displacement or distance moved, or I can say this work is equal to force into dx. So we have the value for force in equation 2. So the work done is equal to m times dv by dt plus v times dm by dt into dx. So w is equal to m times dv by dt plus v into dm by dt into dx. Let us take it as equation number 3. This work done by the body is nothing but it is the increase in kinetic energy of the body. This work done is nothing but it is the increase in kinetic energy of the body, or I can write the increase in kinetic energy or the change in kinetic energy dEK is equal to m times dV by dt plus v times dm by dt multiplied by dx from equation 3. Now let me bring this dx inside. If I bring, I will get m into dv by dt plus or into dx plus v into dm by dt into dx. As per the definition of the velocity, v is equal to dx by dt. So distance traveled divided by the time taken is our velocity. See here, we have one dx by dt which I can replace v. I have another dx by dt here which I can replace it by v. So replacing this, I will have dEK is equal to m into v dv plus here one v, another v here. So it is v square dm, which I am going to refer it as equation number 6. Sorry, equation number 4. According to relativity, the variation of mass with velocity is given by m is equal to m naught divided by root of 1 minus v square by c square, where here the m naught is called the rest mass and c is the velocity of light. Okay, let me take it as equation number 5 and let us square this equation. Squaring on both sides, we get m square is equal to m naught square divided by 1 minus v square by c square. When we square this square will go, square root will go, then cross multiply, you will get m naught square, the whole thing divided by c square minus v square, the whole thing is divided by c square. This can be written as m naught square. When it goes, it becomes c square divided by c square minus v square. So we have m square is equal to m naught square c square divided by c square minus v square. Or you can write this as m square c square minus m square v square equal to m naught square c square. Or else this can be, this minus m square v square is taken to the other side. When we do, we get m square c square is equal to m naught square c square plus m square v square. I am going to name this equation as equation number 6. Now I would like to differentiate this equation 6. Differentiate equation 6. We know c is the constant. C is a constant. M naught is also a constant. When we differentiate a constant, we yield 0. So now let us differentiate this. So we know c square is a constant. So when you differentiate, you will get c square as a constant, and when you differentiate this, you will get 2m dm. Then moving on to this term, m naught is also a constant, c is also a constant. When you differentiate this, you will get 0. So this is equal to, but in this case you could see m is also a variable, v is also a variable. So you have to differentiate it by uv method, that is d of uv is equal to u dv plus v du. So when you differentiate, you keep m square constant, and when you differentiate this v square, you will get 2v plus dv plus, and keeping v square constant, you differentiate m square, you will get 2m dm. When you look at this equation, you could see 2m is common in all terms. So I am dividing it by 2m. When I divide, I get c square dm is equal to m v dv. 2 and m will go, plus this 2m will go. So we get v square dm. So let us take it as equation number 7. Now let us compare this equation 7 and this equation 4 here. The right hand side of equation 4 and 7 are same, so that we can equate the left hand side of equation 4 and 7. Equating equation 4 and 7, we get d of ek is equal to c square dm. So let us take it as equation number 8. See, look at equation number 8. dek is nothing but this is the change in kinetic energy, and c square is a constant. dm is the change in mass. dm is the change in mass, which states that the change in kinetic energy is proportional to the change with the change in the mass. If there is any change in the mass, the kinetic energy of the body also changes. And we all know that when the velocity v is equal to 0, the kinetic energy possessed by the body ek is also 0, and the mass m will be equal to m naught, the rest mass. See, when the body is at rest position, there will be no velocity, so the velocity is equal to 0, and the kinetic energy ek will also be equal to 0. Then the mass possessed by the body is equal to the rest mass m naught. If the body possesses some velocity v, then it has some kinetic energy ek, and the mass is given by m. So with this, I am going to integrate this equation 8. So integrate equation 8. So what is in the left hand side? dek. So the kinetic energy varies from at velocity v equal to 0 to the velocity v equal to, it is ek. On the other side, what we have? c square dm. It varies from m naught to m. So the lower limit is m naught and m. So when it is at rest position, the mass possessed is m naught. At some velocity, the kinetic energy is ek and the mass is m. So when we integrate, this side we will have the integral of dEk is Ek between the limits 0 to Ek. On the other side, we will have c square being a constant. Integral of dm will give us m between the limits m0 to m. So we have Ek is equal to c square times m minus m0, or Ek is equal to mc square minus m0 c square. This is the kinetic energy possessed by the body, or you can call this as a relativistic kinetic energy. You can call this as relativistic kinetic energy of the body. If body is at rest, then the energy possessed by the body is completely because of the potential energy Pe. This is then the energy stored internally in the body, which is the rest mass energy. It is called as the rest mass energy m0 c square. So the Pe, or we can call it as Ep, is equal to m0 c square. But the total energy possessed by the body E will be equal to the sum of potential energy plus kinetic energy. So E is equal to Ek plus Ep. So what is our Ek? mc square minus m0 c square, and Ep is plus m0 c square. So cancelling out this and this, we arrive at E equal to mc square. This is the most celebrated Einstein's mass energy relation, E equal to mc square. This E equal to mc square establishes the relationship between the mass and the energy, which means the energy can be converted into mass and the mass can be converted into energy. Energy and mass are interconvertible. E and M are interconvertible. And it also answered the how this cosmic ray shower happens, that is how pair production and annihilation of matter happens. It also explained the process of nuclear fission and nuclear fusion, how the mass disappearing in the fission and fusion appears as the energy. So, and this celebrated formula E equal to mc square is the responsible for the destiny of Japan. This is the formula behind how the nuclear bombs are made. I hope I made this derivation easy and simple as possible. Thank you for watching.